All right, so I'm going to talk about the the status of SDO at the end of solar cycle 24. First off, the spacecraft is doing great. We have hundreds of years of station keeping propellant left, but on the other hand, we have just enough to get to our parking orbit at the end of the mission. We don't have any new major issues since the beginning of the last extended mission back in October 2017. The instruments are running great. They're still producing science data that meets the level 1 requirements of the original mission. The dedicated ground system is in an excellent shape, although it's because people work on it continually that it remains in excellent shape. And we continue bringing on new people to run the instruments and run the ground system, assuring that we can continue as long as we can. And SDO is producing breakthrough science, both as a standalone mission and as an anchor for the Heliophysics System Observatory, and also because we simply provide data to an enormous number of people around the world. I would like to pick out two things that I thought were pretty cool. One was that we're starting to see Rossby waves. I am a recovering stellar pulsation theorist, so it's nice to see things like these movies that I used to make back when I was doing this kind of thing with the Rossby waves. And here's 3 different ways to see Rossby waves. Time distance helioseismology, granular tracking, and tracking bright points. And over the next couple of years, 10 years, however long we can, I'm sure people will argue about who has the best solar Rossby waves. The other thing I noted was coronal dimmings. They're really nicely seen both in the Eve irradiance measurements and in the AIA images. And the irradiance measurement has actually been adapted to stars in a mission proposed to look at sun-like stars using the same techniques. But the cool thing that I saw was that the image analysis of coronal dimmings has led to a variety of ways to look at dynamic phenomena on the sun and provides kind of you can't do a movie and interpret the page, but you can kind of show the time dependence by on the left, where the Sauer paper shows the brightest points as a function of time. And you can see whatever this thing was, it started and moved out away from the center of the image. And then on the right is an adaptation of persistence mapping from both coronal dimming to mapping the ballistic or near ballistic or non-ballistic falling of material during a prominence eruption or filament eruption that happened back in the early parts of the mission. The SDO Science Community, our goal is to make access to the SDO science data and data products as easy as possible. And this seems to be working because we have over 5,000 referee publications, 62 PhD dissertations. And the thing that's pretty cool is that the nationalities are the first authors of refereed papers. We have 56 countries represented with the first authors, and at least another 18 people if we go into the next level of co-authors. So that's a pretty good fraction of the people that work on solar physics. And here's a publication chart. We put this in our senior review to show that we're continuing to produce science output. And so at the beginning of 2020, the prediction would be that the average, the big broad red line going across there at about 540 or so, would be our guess for 2020. And I've looked back at 2020 this past week, and we had 570 publications. So we continue to produce excellent science even after 11 years. We spend a lot of time helping people use our data, and we currently have about 18 petabytes stored in the SOCs. and that's something like 100 times the HST archive, 20 sometimes more than any other space-based solar mission. And we continue to have steady outflow of data at a pretty good clip. This virtual workshop today was originally planned for last October as a face-to-face meeting. It was delayed until June of this year, and eventually, because of the issues with traveling and having to obtain a visa or apply for a visa 6 months in advance, we decided to convert it to this virtual format. And then the next face-to-face SDO Science Workshop is planned for next October. We also have a lot of nice citizen science results going on. Here is one of the examples that we did in the past mission, the 2019 Mercury Transit, where we were able to pump out 200 terabytes of data to millions of users over the time of the transits. But once again, it's not just the citizen science, it's also the really cool things that people can do when they're given nice data. And here are two pictures, time-lapse pictures of the two Mercury transits we've seen produced by Monica Bobra out at Stanford. I would really like to keep SDO going for the 2032 transit, but I have to have some realistic expectations, and I probably don't expect it to be able to observe the 2117 Venus transit, although that would be really nice. For the people that like to do hardware, we have to run our own ground station. We have 2 antennas out near White Sands and a considerable amount of electronics to take care of that, receive the data, get it ready, and ship it off to the instrument teams. When we hope to refurbish, and for the real hardware people, we hope to refurbish an ACA, which pretty much is a bunch of electronics that you pay a considerable amount of money for. But the ones that we have are quite old. They were installed well before launch. And so our goal is to refresh them over the next couple of years and keep the SDO ground station in great shape for the current extended mission and for extended missions to come. We also have an active calibration rocket program. We have one coming up in the summer of 2021. I couldn't find the Black Brant number, but it's planned and we're working schedules. I think the current schedule is to have it go off in September of this year. And why is this important? It's because the calibration of EUV instruments tends to change with time. And the graph in the upper right shows the degradation curves for the AIA 304 channel and for some other instruments, the MEGS and the ESP instrument. And you can see that it's not just a simple curve. It goes down. When you bake out the CCDs, it recovers and it goes back to declining. And all these complications that come in with the running of the instruments mean that we have to track the degradation fairly well, and the rockets allow us to do that. The permanent data archive has been assigned to the Solar Data Analysis Center at Goddard. We're working at this time to figure out how to build and populate it. And our first thing is level 0 data is being transferred because that's a good test, and it's not the kind of thing that people ask for, so we can transfer it to the permanent archive and not confuse anybody. SDO's third extended mission was approved in December of 2020. We have 5 science objectives that focus the efforts of the science teams, but not necessarily the external users of the data. And you can read them here. They're similar to the ones we've had before, but in general, we are trying to look at the life cycle of the magnetic field of the sun and what is going on to create the magnetic field, disperse the magnetic field, and destroy the magnetic field. All right, it has been a busy Solar Cycle 24. Keep up the good work, and thank you for supporting the Solar Dynamics Observatory.